Alright, it's a beautiful day up here in the middle of nowhere. We've got a SWER line, which is a single wire earth return line here. This is the transformer, and we're going all the way down through the forest. And the problem with the SWER line is that when a tree comes down, it costs them, I don't know, 10, 20, 30, 40 grand to fix. And so they've disconnected that, and in the meantime they've been running on generator, which is costing quite a bit a day. And all that is running is what we see behind me is a comms tower. So that is a, I won't say who, but it's one of our forces comms towers. And inside this little shed here, g'day Chris, yeah, Chris and co have been putting this together inside the little shed with the boring comms equipment, the radio, and we have a little Victron setup. So what we've got here is we've got 3-in-1 batteries, 10 kilowatt hours each. So we've got 20 kilowatt hours of storage at 52 volts. We've got solar panels which have not been put up yet, but they're getting put up now, and we're coming through a charge controller into the batteries, which is basically coming onto this DC bus. From the DC bus we're going out to an Orion 48/12 converter, and that is converting down to a 12 volt bus, which goes to these nice little 12 volt batteries, and all the gear is 12 volts. So that's going to be nice. They don't have to have any 230 in here. They have had 230 in the past, as you can see, with an old fluoro setup. Got an old 230 volt board, but rather than upgrade that, all the rest of the gear is just running on 12 volts, so there's no point in running 230 anymore. But the reason for having a 48 volt bank is we wanted a decent amount of storage, and to do that in 12 volts is, well, you've got a lot of batteries that need to go in, and also to charge at 12 volts you would need 280 amps of charge capability, and this is just 70 amps. Okay, so at 48 volts you can use 1/4 of the amount of charge controllers as you can at 12 volts. So it's actually a lot cheaper to do a 48 volt system and then drop it down to 12 volts. We need 40 amps of potential current, because this equipment will actually draw 40 amps periodically. So that's the peak draw, and we've only got a 30 amp converter, but the batteries will provide the other 10 amps as required. And of course we've got isolation for everything, DC, DC, DC isolation, and we have a ServoGX that basically just monitors everything. You can see there it's off. We've got no inverter, we've just got a battery setup and a charge controller. So this is just monitoring the 48 volt side. This doesn't have any monitoring at all, it just sits there and follows. So it just converts 48 to 12 volts, no problem. Okay, that's about it. Yeah, that's it. Just tidying up now. Yeah.
Finishing up, tidying up.
And we've got a generator here, but we're not going to connect that in yet. It's the middle of summer, so we've got a bit of time before we connect the generator in. Cool, enjoy.